This is the first video in a chapter about the essential ideas of chemistry. We're going to start by talking about macroscopic terms in chemistry, and the topics will be what chemistry is, what the scientific method is, and what some of the important terminology is that you'll need to talk about chemistry in this class. So first we'll start out with the basics. What is chemistry? So chemistry is called the central science. So we'll draw it at the center of the page here. And this is because chemistry is central or related to lots of other branches of the scientific fields. It's related to things such as environmental science, related to material science, figuring out what different materials are made of and how to optimize their properties. It's useful for nanotechnology, specifically making very, very small devices. It is essential for physics, essential for math, or rather math is important to chemistry. Chemistry is useful for engineering. There are chemical engineers. It's useful for geology, the geology of different minerals. And of course, it's related to biology. So much so that there's a specific field called biochemistry that links them together. So chemistry is central to lots of other different types of science, and that is a good reason to learn more about chemistry. So what is chemistry? Chemistry is the study of the composition, or what things are made of, the properties, or how a substance behaves or acts, and the energy, or how it reacts, of matter. Matter being anything that has mass and takes up space. So we're going to be studying these different features of chemistry, and that's going to lead us to ask questions. Scientists love to ask questions. So here's an example of some of the sorts of questions that you might ask that we'll be answering in this class. So chemistry asks questions like, what makes heavy water heavy? Or maybe the question, why are alkali metals so much more reactive than other metals? Why do they explode when they touch water when things like copper and lead and iron don't do that? Questions like, how do helium balloons float in the air when balloons that you blow up with your mouth won't float, or at least not for very long? Or questions like, how do antacids work? Why do you take them when your stomach is upset? How does that help relieve your discomfort? These are all questions about everyday interactions and activities, and they're all questions about composition, properties, and energy of matter. These are the types of questions that chemistry will aim to answer. So, how are we going to answer these questions in this course? Or in your life? Before we had Google, we had another tool to answer these questions, and that tool was scientific method. So let's talk a little bit more about the scientific method, which is sort of the problem-solving process that you and other scientists use to understand and predict and make observations and make plans for proving how things work in our universe. So you've probably learned about this in any previous science courses, but we'll talk about it just to make sure everyone's on the same page. So the first thing that a scientist does at the beginning of the scientific method process is they make an observation. This could be you walking along on the sidewalk, observing something that you've never seen before. This could be you in a formal laboratory setting, observing an experimental piece of data that doesn't make sense. Just noticing. Science is about noticing things that are interesting to you, that you can't explain based on the science that we know already. And the natural thing to do after you witness something is to form a hypothesis about why that thing happened. So that's an important piece of terminology for this course, so let's clarify that while we're here. Hypothesis is a plausible explanation for an observation. So a hypothesis is a scientific guess. It's a potential explanation for your observation that could be true, that is not validated by anything except your gut feeling. So once you form a hypothesis, the obvious next step is to prove what you've just hypothesized. And you prove things with data, and data comes from experiments. So the next step is to perform an experiment to test the hypothesis. And these experiments look different. Sometimes it means going back to where that thing happened and waiting to see if that thing happened again. Sometimes it means purposely setting up a situation where it'll happen. Sometimes it means watching to see if you can create it by doing something different or by doing the same thing. In any case, you're doing some sort of a purposeful observation to watch for that observation again and to collect data to prove whether your hypothesis is true. So you do an experiment and you collect data and evidence, and then you ask the question, does this experimental evidence support the hypothesis? And there's no judgment here. Science isn't going to judge you for getting it wrong. Science just wants to find the correct answer. So your answer could be yes, or your answer could be no. So if the answer is no, and the experimental evidence you collected doesn't support your scientific guess, that means your hypothesis is incorrect, which is okay. You can always make another hypothesis and try again. We are not all right the first time. And if your hypothesis is incorrect, then you need to return to the form a hypothesis step and form another one. It's possible you might even be able to find a better hypothesis that fits the data you collected without having to collect it again. So if the evidence you collected does support your hypothesis, and you have lots and lots and lots of evidence that supports it, it can eventually grow up to be big and strong and become what we call a scientific theory. This is another important vocab word, so let's pause here just for a second and talk about what this is. When we're talking at the grocery store with our mom or with our little sister and you use the word theory, what you usually mean is some sort of a guess about what might have happened. And in science, we use that differently. If we're talking about as a guess, we use the word hypothesis. When we use the word theory, we're talking about something that we definitely know for sure. So a scientific theory is something that is confirmed, a confirmed explanation. That explanation is supported by evidence, lots and lots of evidence, hopefully from several different scientists, and by repetition. We never believe something we only saw happen once. We have to be able to reproduce the situation and to be able to explain it with the same scientific theory every time it happens. So a scientific theory is something that the wider scientific community generally agrees and accepts to be true, such as the theory of gravity. And so this is most of the time where we think about the scientific method as stopping. We reach a scientific theory, we understand how it works, our job is over. But a lot of those scientific theories were written an awfully long time ago, 1700s and 1800s. And sometimes here with our modern advanced technology, we discover new evidence, a new thing related to the theory of gravity that we might not have known before. And just like when we did an experiment before to form the theory, once we discover new evidence, we have to see if it fits into that theory that we made. Can the theory be modified? to include the new evidence. Every time you do an experiment, it should align with a scientific theory. And if you can consistently prove that there is new evidence that doesn't relate to a scientific theory, then you're going to have a problem. Let's see. So if the answer is yes, so if we learn something new about gravity and that matches what we already knew in our scientific theory about gravity, then great. That scientific theory is even more robust than before, it's even better well defended, and it's even better supported by our new instrumentation and data. But if repeated experimentation shows that it can't be modified, then the theory may be incorrect, or it may need to be modified. Partially correct theory. And if the theory needs to be modified, we return to the hypothesis phase. So the important things I want you to take away from this are, number one, the scientific method is something that you use every day without thinking about it. You notice something, you think about an explanation for why it might be true, and then you repeat the activity to try and confirm if that explanation is true. Secondly, a theory is something that is a confirmed explanation that's supported by evidence and widely accepted. It's not just an idea or a guess. It's a well evidence-based explanation. And thirdly, just because your textbook says that something is a scientific theory and we agreed it was true in 1750, doesn't necessarily mean it will always be true. Sometimes we collect new evidence and we discover that the theory needs to be modified and we have to go back and make changes. In the next video, we will go over some scientific terminology to complement our new knowledge about the scientific method.